Okay, my wonderful cluster students, this is the first lesson out of chapter 5. Even though the PowerPoint says chapter 6, it's chapter 5 in our updated book. Um, this hopefully will go easy. Properties of exponent is the one quiz that I always have in class that everybody has to retake just because of the nuance of it. Seems easy, but when you start getting into really creative problems, things could go awry really, really fast. So I'm hoping we get this. You had it before in Algebra 1, so I'm reviewing and just making it a little bit more robust. And robust means like more. All right, so of course you have notes with these. It should be in Schoology if you want to follow along. And here we go. Hopefully I can keep this at under 12 minutes. It's going to be hard, but all right, here we go. So first is the property, the product of powers, or the product of powers. That means when I multiply two variables or two numbers together and they have exponents with them, I'm really multiplying that number out. So b to the third times b to the fifth is b to the eighth, because that's 3b's, b times b, and 5b's, which makes b to the eighth. Going, it says simplify expression with multiplication. So let's do more variables. And this actually you should understand. This one is actually easy to understand. So what's really happening is I just have a long multiplication term. I don't have a plus sign there. It's just a really long multiplication problem. So it's make it easier if I look at an expansion form to understand the rule. And I've moved and rearranged things. So all the A's that are being multiplied by together and B's are being multiplied together and the integers are being multiplied together or next to each other. So when I simplify that, I get -2 times -5, a to the fourth, b to the fifth. Well, let's go back and look at the original problem to see if I don't want to expand it all the time. So what can I do? So if you notice, just the power of a product is just adding the exponents. So a to the third power plus a to the first. That b, and I have this issue too with kids. That 4 is only with the b. It is not with the a. The a is to the first power. So a to the third and a to the first, that's 3 plus 1, that's a 4. B to the first and b to the fourth being multiplied is 1 plus 4, that's b to the fifth. So easy to get. So actually you got slide. So I'm going to count down 3, 2, 1, so you can pause. And hopefully you're back and you tried the problem. Let's look at the answer. -15 x to the fifth, y to the sixth. I hope you got that right. If you don't know why, well, -3 times the 5 is a -15. Okay, the x to the second and x to the third. Oh, add my exponents, I get 5. Y to the first, because the y is just y, is 1y. And y to the fifth would make y to the sixth. So some people would have picked B, and that's why it's there. So, but the answer is A. All right, let's look at the next rule. That's the quotient of powers. The quotient of powers. So what that's saying is if I have the same variable with different exponents being divided, I can simplify that by subtracting my exponents, which makes sense because what I'm effectively doing is actually taking it and turning it into a product of 1. So if I have 1, 2, 3, 4, 5, I need one more x over product of 1. Well, and what's left over? Because anything that's the same in the numerator, the same in the denominator turns into 1. I don't need to see 1, so they're gone. So x times x times x times x is x to the fourth. That's why that answer is the explanation for that. All right, so you guys try this problem. Now, do you see how it got expanded? Because that's really what's happening. The first time I teach this, instead of doing like the shortcut, let's just see what's happening. So, well, gone times 1, right? Then C's. Oh, okay. All right, so let's look at our next line. C times C times C, D times D times D. And then I just need to simplify my 15 over negative 3. Well, what's 15 divided by negative 3? Oh, it's a negative 5. So I have negative 5, c to the third power, d to the fourth. Well, let's look at it mathematically. Let's look how we could have gotten from here to here quicker than doing the expansion. All right, well, 3 and 7, if I subtract those, I get a negative 4. Well, that just means it was more in the denominator. So I'm going to leave it there because there are more 7s in the denominator. I don't want to write a negative. So I have d to the 4th. So I need to look at that as 7 minus 3 is 4. There are more d's in the denominator, so I leave him in the denominator. So when I look at c to the 5th divided by c to the 2nd, all right, let's subtract. Our exponent is 5 minus 2 because they would have turned into a product of 1, right? As you kids like to say, cancel, but c to the 3rd. And then 15 divided by negative 3 is negative 5. So now let's try a problem. All right, so you guys try that problem. I'm going to pick it up in 3, 2, 1. Okay. Now I'm not going to expand it out, but I am going to separate it out into their own fractions. So like the variables and my integers into their own fractions. So I have 4 over 12, and I have a over a to the 4th, a to the 2nd. Then I have b to the 5th over b to the 2nd. And I have, I'm writing too hard, and that's why it keeps popping. C over c to the 3rd. So if I look at that, well, what's 4 over 12 simplified? 3. So I should have a 3 in the denominator. It's 1/3. 1 over 3. So A makes no sense other than if you subtracted 4 minus 12. No, which people do all the time. It drives me crazy. So now we're left with B, C, and D. Well, let's look at our answers for A. So we have 4 minus 2, which is a to the 2nd power. Well, a to the 2nd power should be in the numerator. So that's good. That doesn't help me cancel. Now let's look at B. So b to the 5th, b to the 2nd. So 5 minus 2 is 3. Should it be in the denominator or should it be in the numerator? It should be in the numerator, which is correct. So 3 minus the 1 for C gives me 2. Well, should C be in the numerator or denominator? Where were more of the C's? It is in the denominator. So our answer is B. Hopefully you got that, because we're going to keep going. All right, now we're talking about the negative exponent rule. So negative exponents, to me, you can think about it, it is in the wrong position. A negative exponent in the numerator means it'll be positive in the denominator. A negative exponent in the denominator means it will be positive in the numerator. Okay, so let's actually try it. I actually like to go into more detail, but then the video is going to run. So we're going to keep going. We're just going to try it. So we have c s to the 2nd over s to the 10. Easily from what we just learned, we know it's s to the 8th. Where should it be? In the numerator, or should it be in the denominator? I hope you would say denominator because there's more s's in the denominator. So they think about it this way. Simplified expressions cannot have negative exponents. Well, it was more in the denominator anyway. So that's how I want you to say. If you see a negative exponent, it meant that it was more in its opposite position. So if it's a negative exponent as a numerator, then you need to move it down to the denominator. If it's a negative exponent already in the denominator, move it up to the numerator to make it positive. So we got 1 over s to the 8. You guys try that. It only takes a second. 2, 3, 1. Obviously, 7 minus 3 is 4. Should I be in the numerator or should I be in the denominator? Denominator, I hope you say. We got 1 over x to the 4. Let's keep going. All right, you're like, oh my God, that looks so long. Well, we're just going to take it one thing multiplied at 8 times. So, and we got to get rid of those negative exponents. We don't want to see negative exponents. Negative numbers on the other hand are okay. Don't you mess with the negative 2. There's nothing wrong with them. So what I'm going to do is let's rewrite this without the negative exponent. So since I put a 1 on that just so I can have all fractions that I can multiply top and bottom and simplify. So if I have 3a to the fifth over 1, well, look, that didn't change. But that c to the negative 2 did change because I don't want negative exponents. It means that it needs to be moved to the denominator. Also, this one changed. Now notice the negative 2 did not move with the a. You leave him alone. He is fine. He is a negative 2. Negative 2 is about the exponents not being negative. So a to the negative 4 moves down to the bottom. And all I'm going to do is simplify. And the only thing that really needs to be simplified is the 3 and the negative 2 can be multiplied to each other. And the 5, let's change colors. The 5, a to the fifth and a to the fourth, they can be simplified. So how many a's are left in this multiplication problem? 1a. Should be in the numerator or the denominator? Numerator. So if I move, I get this. Negative 6, ab to the third. It didn't change. It's c to the second in the denominator. You guys try it. 3, 2, 1. All right, well, I am going to make nice fractions without negative exponents. So 4x to the second times, I keep doing it, x over y to the third. All right. The only thing we need to simplify really are the x's. So this one and this one. Where are more x, denominator or numerator? There are more x's in the denominator. So 2 minus 1x gives you x. So I need to answer with x in it. So a is removed. I also need a 4 that's in the numerator because there's no reason for 4 to go down. It didn't have a negative exponent. See our answer? There you go. All right, we're at 12. I think I am going to pause the video here, start another video, and pick it back up for you guys because 12 minutes is a lot to digest and also a lot to process on a YouTube video. So I'm going to stop it here.